Okay, so today we shall look at linear ordinary differential equations. And on linear ordinary differential equations, these are the only things that you need to know. So they are basically 4 things. So I shall explain one by one, and I shall solve one example applying the concepts that we get, and we shall solve more examples in the other videos to come, so that we can cover most questions, so that we can grasp what really an ordinary linear ordinary differential equation is. So let's start with this. This is called the standard form, and the standard form basically of linear ordinary differential equation is that it has dy dx plus p of x y is equal to q of x. So what it means is you have dy dx, you can have y prime or anything, but it's just dy dx like this, and you have p of x multiplied by y. So you check your equation. If it should have p of x is a function of x only, and that is in front of y like this. So, and then you have also q of x as another function of x only. It could be any function, either sine x or cos x or an exponential function, but it should contain only x's. So if you check an equation and it is in this form, then you should know that that is a linear ordinary differential equation. If it's not in this form, you can try to change it to make it in this form, but if it doesn't work out, then it's not an ordinary differential equation. So the second thing that you need to know is the integration factor. So you are going to use this integration factor to solve that ordinary linear differential equation. So an integration factor is given by this formula. So you can take it down. E to the power integral of p of x dx. So that means you have in your equation you have to identify what is your p of x, then you put it here, then you integrate, then e raised to that one, to that thing, then is the result, and that is the integration factor. So the third step is now to multiply the integration factor throughout the equation. So you multiply throughout the equation like I've done here. I represent the integration factor. So whatever you get it here, you multiply it in the original equation like this. Then you integrate both sides. So if you integrate both sides, you go to the first step. If you integrate this both sides, what will happen is that the left hand side here becomes y times I, means y times the integration factor. So where is this coming from? This is coming from differentiation using product rule. If you look at this thing, it looks like a product rule, if you remember in calculus, which is like, for example, if you differentiate this by product rule, you find that if you differentiate y, it will be dy dx. So it will be y prime, and you keep I, and you add. That's how you do the product rule. So if you differentiate now I, it will be I prime, then you keep y. So this I prime is the result will be I times p of x. That's how linear ordinary differential works. So this is where it's coming from. So if you reach this stage whereby you are integrating both sides, what you have to do is just jump and write it y times I. That's the integration of the left hand side. It's just y times I, as you have seen here. So that is equal to the left hand side. So it will be, you integrate the left hand side, which is I times q of x, and it will look like this. So you find the answer, then you make y substitute the formula, then you have solved. So let's try to apply what I've explained to this example, then you appreciate what I was trying to say. So we have dy dx plus 2xy is equal to x. That's our question. The first step is identify p of x and q of x. So easily you have this 2x here, that's your p of x, and this x is your q of x. So is it in standard form? Yes, it's in standard form. So second step, integration factor. What is your integration factor? Your integration factor will be given by e to the power px, which is 2x, and like that. So it will be dx. So then this, you find the integration factor, then which is what? If you integrate that guy, you find that you take 2 out, then x2 squared, then divide by the power, then it will be then your integration factor will be e to the power x squared. So that's what your integration factor will be like. So now, after you have done this, then you go to step 2. You multiply throughout the equation. So you take this, you multiply throughout the equation. How are you going to do that? Then let's do it. And okay, let's do it like this. You have our integration factor, which is squared. You multiply throughout the equation. Our equation is, the original equation is this: dx plus 2xy is equal to x. So this is how you do it. So when I said we are here, you are going to integrate both sides. So if you multiply this and then integrate it, to the left hand side, it will be y times integration factor. So it just be your y, your integration factor, times your y. So that's how it will be, times your y, and that will be equal to the right hand side. Actually, my right hand side. So I think it's also your right hand side. So this right hand side becomes if you multiply this to ex, then it will be something that is like this. So you have your integration factor, which is x multiplied by x, like that, and that dx. So that's how it will look like. So after it reaches this stage, then you have to find what is the derivative, the integration here. So for this one, we shall use u substitution. So if you have forgotten about u substitution, then it's basically u is equal to I can say that u should be equal to x squared. Then du will be 2x dx. That's du. Therefore, for this one, it's x dx. That means we need to find what is x dx. Then it will be half. If I take this 2, it will be half. Half du will be equal to x dx, like that. So we shall now bring them here. So let's do that. You have y, you have got y times integration factor, and that is equal to the integral, and then e to the power u, our u is this, then x dx, this guy, is equal to this. So I can take I can take half out and keep x and keep du here. So it will be like that. Now, if you integrate this e to the power u, the integration is what? Is e to the power u. So, and then if I substitute back, my u is this one, then the result will be y integration factor is equal to half e, and then I'll bring back it will be x squared plus c. So this is your result. Now, let's say you are writing an exam, and then if you find that this is the answer, but it's not on the options, what you do, try to simplify it further. So you can say y is equal to, like making y subject, then this will go to this side. So it will be 1 over 2, and 1 over 2, if this cancels with this, then it's plus c. If I divide here, it's the same as if I write it like this, minus like that. So there's a negative here. So if I raise it here, there's a negative. So that's basically the answer to this ordinary differential equation. So now let's say if they ask you that this is a solution and this is a differential equation in an exam, and they want to ask that if you want to prove, or maybe they can tell you to find these two. Maybe they can put b here. So they can say you have to find that b. So how you do that is, it's like you're proving, is this really a solution? So how you do that is you find y prime for this. So y prime will be, for example, this is 0, then it will be minus, it will be what? It will be 2, it will be minus 2, 2x c e to the power minus 2. So you can check how you just differentiate this. So if you differentiate this, look, so if you differentiate that, then you have got these two things can help you to prove. So how you do that is, where there's y prime here, you substitute this. Where there's y here, you substitute this. You find that it will give you x. So that means it's indeed a solution. So you can check that one, but I did check, then it's a solution. So that's it, guys. Thank you for watching, and see you in the next videos, and goodbye.